Welcome to the video of transformations of graphs. So first we have our transformation rules. So if you have a function, so your base function is your parent function. So that could be a quadratic, your x squared, it could be e to the x, it could be 1 over x. Any sort of function can be translated or reflected or transformed in some way. So if you have your base or parent function plus d on the outside, then it will move up d units. If it is minus d, then it moves down d units. If you have a plus c in with your x, so if it was like x plus 3 squared or e to the x plus 3, then it would move left c units. If you have a minus c on the inside, it'll move right c units. So it moves left and right because it's in with your x, and your x is your horizontal axis. The main thing that's weird is your plus is going to move left, which is towards your negative direction, so it does the opposite of what you would think it does. This negative on the outside will reflect it across the x-axis because it's switching your y values from positive to negative and vice versa. This negative on the inside with your x switches your x values, so it'll reflect it across the y-axis. A number multiplied by your function on the outside would cause a vertical stretch by a factor of a if the absolute value of a is greater than 1, and a vertical compression by a factor of a if the absolute value of a is between 0 and 1. And then if you multiply something by your x on the inside of the function, you'll have a horizontal compression by a factor of 1 over b if the absolute value of b is greater than 1, and a horizontal stretch by a factor of 1 over b if the absolute value of b is between 0 and 1. So this is a table that's really important to memorize for the test so that you can know how your functions are going to shift if you don't have a calculator. So a composite transformation is when multiple transformations are formed on a parent function or base function. So for example, we'll use f of x equals x squared. So this is your parent function. To graph f of x equals negative x minus 2 squared plus 1, and f of x equals 2x plus 3 squared. So this negative on the outside will be a reflection, and because it's on the outside, it's going to switch your y values, so it's going to reflect across the x-axis. This negative 2 is in with the x, so it'll move it left or right. It's negative, so you would think it's going to move to the left, but it's actually going to go right 2. And this plus 1 on the outside will go up 1. So if we had our normal x squared function, we're going to go right 2, up 1, so that's our vertex, and then it's going to be reflected across the x-axis, so it'll be flipped down. So for our second one, we have f of x equals 2x plus 3 squared. You always need to factor out the number before your x, so it would be 2 times x plus 3 over 2 squared. So that's your f of x. The 2 inside will give you a horizontal compression. By a factor of 1/2. And this is because 2 is your b value, so it would be 1 over that, so 1/2. And then it's being shifted left 3 over 2. So on our graph, if you had your x squared, we'll move it left 1.5. So your vertex is here. And a horizontal compression is pushing your x values closer together. So this is going to be more narrow than our previous one. So here we have our first IB practice question. It says, describe the transformations done on f of x to form h of x if h of x equals negative 3 f of x plus 4 minus 2. So we'll start with this negative. So a negative in the front is going to flip our y values. So we'll have a reflection across the x-axis. The 3 outside of the function is going to be a vertical stretch by a factor of 3. This plus 4 is going to shift our function to the left 2, and this minus 2 will shift our function down 2. So it's been translated left 4 and down 2. So those are all your transformations. And then it says if j of x equals negative h of 2x, the point j 4, 6 on the graph j of x maps to the point h on the graph h of x. What are the coordinates of point h? So to get j of x, you have to reflect h of x over the x-axis. So you have h of x, which you reflect over x-axis. And then you have a horizontal compression by a factor of 1/2. So then that gives you j of x. So we have point j on j of x, which is 4, 6, and we're going to go backwards to h of x. So instead of a horizontal compression by 1/2, we're going to multiply our horizontal value by the reciprocal of 1/2, which is 2. So we'll get 8, 6. And then we'll reflect it over our x by switching our y value from positive to negative. So it'll be 8, -6. So point h is 8, -6. Now we have our second IB practice question. It says sketch the graph of f of x equals 2 to the x plus 2 minus 3. And then find the x-intercept, y-intercept, and horizontal asymptote. So 2 to the x would have a horizontal asymptote at y equals 0. And it would have a y-intercept at 0, 1, and look kind of like this. So our 2 to the x has been shifted left 2 and down 3. So this 0, 1 is going to go left 2 and down 3. Because it's gone down 3, our horizontal asymptote is also going to go down 3. So our horizontal asymptote, part C, will be y equals -3. Our y-intercept is when x equals 0. So it would be y equals 2 to the 0 plus 2, so 2 squared minus 3, which is 4 minus 3, which would give us 1. So our y-intercept will be at 0, 1. And our x-intercept is when y is 0. So we'll have 0 equals 2 to the x plus 2 minus 3. We'll add 3 to both sides to get 3 equals 2 to the x plus 2. We'll take our base of 2 and make it the base of a logarithm. So we get log base 2 of 3 equals x plus 2. So our x is going to equal log base 2 of 3 minus 2. So we can put that in our calculator and get that x is approximately -0.415. So our x-intercept is -0.415, 0. So our graph will look like this. And we have our y-intercept is 0, 1, horizontal asymptote, y equals -3. So it says the function f of x is reflected over the x-axis and translated by the vector 2, 12 to form g of x. Write the equation for g of x and add it to the graph. So our f of x is reflected over the x-axis, so we'll have a negative on the outside, and translated by the vector 2, 12. So 2 means we're adding 2 to x, and 12 means we're adding 12 to y. So that'll be our negative f of x minus 2 plus 12. So our g of x equals negative f of x, so 2 to the x, and instead of x, we're going to do x minus 2 plus 2 minus 3 plus 12. So this becomes negative 2 to the x plus 3 plus 12, which is negative 2 to the x plus 15. So g of x equals negative 2 to the x plus 15. So if we reflected 0, 1 over the x-axis, we'd get 0, negative 1. And then we want to go right 2 and up 12. So at 2, we'll have the point 2, 11. From our negative 2, we can reflect it over the x-axis. And then we go right 2 and up 12. So it would be at 0, 14. So our function will look something like this. And our horizontal asymptote will be when y equals 15. So it doesn't fit on the graph super well, but that's kind of what it would look like. So in summary, we have our transformation rules that are important to memorize. And then we have composite transformations, where multiple transformations are done on a parent function or the base function. So for this video, the most important thing to really know is those transformation rules so that you can use them on the test. But that's all for this video. Thank you so much for watching.